So, cloud anti-patterns, that's what I'm going to talk about today. And I wanted to give you a little bit of history behind why and how I came up with this talk. So, I work at Pivotal as a Cloud Foundry architect, and a lot of my job involves actually working with Fortune 500, Fortune 100 customers as they're starting down the path of cloud native application building. And usually there are great meetings, and then there are meetings where it leaves me frustrated, and and I usually come home and I rant to my husband, and it's like there's a fist waving situation and table thumping situation where I'm literally telling him, I can't believe he did that, or I can't believe he thought about doing that. And I think it got to a point where he just turned to me one day and said, you need to tell someone else about this. So because it's not useful to me. So you really need to tell people who are actually going to be benefited by this. So that's how the idea for the talk came by. And what I'm going to talk about today, it's going to be 9 anti-patterns. It's essentially a collection of almost like short stories, what I've actually seen customers do and how it has gone horribly wrong and how we have been able to catch them before they've actually gone ahead and done that and kicked themselves in the foot and then blamed all sorts of external factors for it. So a little bit of who am I? So I am primarily a software developer. I currently work in Pivotal as a Cloud Foundry specialist. You can follow me on Twitter at Cloud Foundry Yard, stalk me on LinkedIn. So my history is in search in NoSQL technology way before even NoSQL technology was cool. And I've spent a significant amount of my career in data mining and log mining. So previously, before Splunk, I spent a significant part of my career in UBS, Splunk, MarkLogic, and so on. So today I get to work with Cloud Foundry primarily and customers in the industrial vertical, so those who are trying to build Internet of Things kind of applications, and they're trying to deal with the challenges of scale at that point. So while I'm not doing that, I'm also a certified TRX trainer, so it's something that came out of the Navy SEALs, and I'm also a fitness junkie, and most of the time that I'm not coding, I spend with my 2 German Shepherds. So this should tell you that I love Simpsons. So I don't know how many of you guys remember seeing this episode, but it's basically where Grandpa Simpson is waving his hands at shaking his hands at the cloud, and he is blaming the cloud. But it's very, very characteristic of what I see a lot with customers, where when they start down this cloud native journey and when they start down this DevOps path, and then they create a cloud council, and there's a lot of new positions coming up in companies where VP of cloud strategy, whatever that means, and then VP of cloud council. And they started out with good intentions, and when they start actually implementing something without completely understanding all the pitfalls, then it's very, very easy to blame the messenger. So it's very easy to say, hey, that's the thing that I don't understand, so that is the thing that must be at fault. So that's what I'm going to focus the majority of my talk on. So don't worry about these. I'm going to talk about all these in detail, but I'm a huge fan of setting the stage, defining things, and depending on who you ask, you're going to get multiple definitions for the same thing. So let's go over a couple of definitions. So the first one, probably the most overused term outside of big data and containers today, is microservices. So everybody wants to use it. Everybody pretends to be using it. Nobody tells other people, and then there are these random things on Twitter about how things failed and kind of scary messages and so on. And then there are a handful who are actually doing it right. So what do microservices actually mean? It's actually a software design architecture pattern. So you take a huge complex application, you break it down into small independent processes. Ideally, they should be communicating with each other using language agnostic APIs. And ideally, they should be small, they should be autonomous, they should be very loosely coupled, but they should all be working together, focusing on doing one thing and one thing only. The next most overused term is containers. So what exactly is a container? It is a lightweight, isolated environment. Isolated in the sense that it is isolated from the other containers, from the rest of your VMs, from the rest of your infrastructure, and it can run a service or an application without an inherent reliance on the underlying operating system, on a separate operating system. So I'm pretty sure everybody here has either heard of or has actually worked with Docker, Warden, Garden, Rocket, and there are others too, but these are the ones that are most commonly thrown out there. The other one is continuous integration. So I know that there are other folks here who talked about how when in the quest to automate everything, things usually tend to go horribly wrong and you end up automating error chains. So continuous integration, what is it? It's basically, ideally, you should be merging all of your dev copies into one shared mainline multiple times a day, and this has to be done automatically. And continuous delivery, again, bear with me for this last definition. So ideally being the key word, is this is an approach where you have multiple teams, they are producing ideally valuable software, and it's short, definable cycles, and they're releasing it very reliably, very predictably, and at times, ideally, it should be done automatically. So some of the most common ones are, there's Concourse, Jenkins, Bamboo. I'm pretty sure a lot of you are familiar with a lot of these tools. So now we actually get to dive into what the anti-patterns are. So when you look at any application, when you look at the life cycle of an application, right from development to ops, and when you put it in the cloud-native context, there are three common parts to it. So the first one is microservices, writing microservices, deploying them in containers, and this is largely a function of development teams. The next one is continuous delivery, which is largely a function of the ops teams. And the last one is continuous integration. Ideally, it's a function of development and operations. There has to be a degree of collaboration here for this to work. So the sweet spot between all three of them, where all three overlap significantly, is where a cloud-native platform, something like a platform as a service like Cloud Foundry, comes in. And the reason for that is because it abstracts away the pain of managing containers at scale. It abstracts away the pain of managing microservices, scaling your microservices elastically, making sure all the microservices know about each other, talking to each other, and so on. And it also hooks up with build pipelines and other logging software, and it has various other features to it. But the beauty of it is it brings a large component of this in one platform. So a lot of customers, when they come to Pivotal and they say, hey, we need to build this application and we need to do something drastic because we are not able to release applications on time, they usually do something like this, where they start down the path of either automation or they start down the path of either continuous integration. They do one of these things at a time, and they, in the process, end up creating more silos of technology management. So they pretend that, if I ignore this spot, if I basically bury my head in the sand and pretend that it doesn't exist, maybe it'll just go away and everything will just work. But that's really not the case. And why should you not leverage something like Cloud Foundry when it actually spans across these three pieces? And it's actually giving you the benefit of that. It takes away a lot of your pain and allows you to focus on other things. So that is the first anti-pattern. The second one I keep coming across most frequently is this trade-off against, should I do risk mitigation or should I do innovation? So this is the most common war, right, between developers and the operations team's priorities, where the problem is companies know they want to innovate, businesses know they want to innovate, and the development teams as well as the operations teams are aware of this. And they want to release cool features yesterday. They want to release it as fast as possible, and then they do agile programming, pair programming, and whatnot. But all that is useless if you're not actually able to deploy anything to production for various reasons that we have all discussed over the course of the past 2 days. So what ends up happening is, although a feature is ready to be released, there are multiple concerns. Like, it might be simply that the operations team doesn't have the bandwidth to support it, or they have to think about high availability, they have to think about disaster recovery, they have to think about the uptime for the features, the scaling for the features. All of these concerns are completely or almost invisible to the development side of it, because all they want to do is they want to write cool things, they want to use cool technologies and release the features out. So what ends up happening is everyone's unhappy, the business is angry, and everybody's favorite blame child, everybody wants to blame IT ops. And that's not really fair, because IT ops is tasked with keeping the lights on. They have to actually make sure that the application is up. It doesn't matter how many features it has. It's not going to be used if it's not up. So this is kind of the situation, right? Like, I want to release all these new cool features, and this is actually a situation that I had dealt with a customer where the developer was very excited. He was all in. He wanted to, and he was the kind of guy who would basically spend all day, all night, all weekends, and he basically just had twin kids. So think about that. He's that kind of a guy. So he would rather code than do other things. So he was a very, very enthusiastic guy. And their operations team, it was completely focused on putting out existing fires. So they simply didn't have the bandwidth to support teams like his. So what is an elegant solution to this? So you don't really have to choose if you select the right technology. If you create technology silos for yourself, you're going to be forced to choose, should I focus on risk mitigation, or should I focus on actually innovation, or do I need to make a trade-off somewhere in between? So if you select the right platform, and the reason I focus on Cloud Foundry is quite frankly, it's not because I work for Pivotal, but it's mainly because Cloud Foundry is a fantastic platform, and it is also, by the way, open source, so you should go check it out. So something like Cloud Foundry, what it does at its core is it is a self-healing platform. So for example, when I'm deploying applications to Cloud Foundry, it automatically allows me to distribute the applications across multiple availability zones, across multiple data centers. I don't need to do anything additional to do that. It's a configuration setting as long as I have the data centers set up. The other cool thing it does is, let's say an application, X number of instances of an application go down, it will automatically correct that situation. It corrects itself because it's constantly comparing what needs to be out there and what isn't. The third thing it does, it's kind of like Inception, because it monitors itself and it resurrects components within Cloud Foundry that go down. So that, I think, is really, really cool. And the other thing that very, very few PaaS solutions out there in the market have is it also goes a level ahead and tries to resurrect the VMs themselves. As long as the infrastructure as a service provider allows it, it communicates with the IaaS layer and resurrects VMs if there are VMs that Cloud Foundry is running on that goes down. And the other interesting thing is there are two components to Cloud Foundry. So there is an operations manager piece, which is what the ops team works with, which is what they use to control the entire deployment. And then there is the application management part of it, which is what developers deploy to. So let's say that one half, the critical half of Cloud Foundry, that is the operations manager director, goes down. You're still going to have 100% uptime with your development, with your applications that are out there, because there is no inherent dependency between these two pieces. As the only dependency is to install and control the entire environment. It's fairly easy to recreate the operations manager part of Cloud Foundry with a configuration file, and when you reinstall it, you re-import the config file, and everything is going back to normal exactly as it was. So it's a bold statement to make, but with something like this, you will almost always get 100% uptime unless and until you do something really, really silly and you don't set any availability zones. You maybe deploy only one instance of your application, things like that. So this is kind of a paradox, because the monolithic microservice is something that I have seen so many times, I don't even want to admit it, but it is a very, very common problem when customers start looking at building applications in a microservice-oriented way, and they start thinking, okay, how do I break my application down? And I was actually talking to the enterprise architect in one of the large Fortune 100 companies in the industrial space. And So at Pivotal, we use Google Hangouts for everything, but this was on the phone, so he couldn't actually see my face, and I couldn't actually see his face. So he started asking me about how many microservices can I deploy per container, and he started asking me about can I deploy more than one microservice per container, and then I was wondering why exactly is he asking me that, because the whole premise of building microservices is you don't want dependencies, you want them to be loosely coupled. So I kept digging and I kept digging and I kept digging, and he ultimately said that he doesn't want to have to manage multiple containers, and he doesn't want to have to spend on managing multiple containers. And then the whole point of using something that inherently takes away the pain of container management is you don't have to deal with this temptation. You don't have to create small monolithic applications within your microservices architecture, because now what you're doing if you do that is you're taking something from a platform you kind of know, the old way of doing things, and you're moving it to a platform you absolutely don't know anything about. So that's going to compound your problems. So if you have if you want to group similar microservices in the same container, don't do it. Because what's going to happen is when you want to change something, and it will change, you're going to be unable to scale unless and until you identify all the dependencies within that container for all the microservices. You're going to be unable to deploy changes as quickly and as frequently as you want. So you're going to get a microscopic version of the monolithic problem in multiple parts of your application. So that's going to essentially cause a monolithic creep. So don't basically violate this cardinal rule, that is, deploy one microservice per container. Resist the temptation to do more than one for whatever reason that makes sense today, because 1 week later, you're going to have to redo it. So the next one is interesting, because this is, again, something that I saw at a customer where they were all in on the whole way of building cloud-native applications using microservices. They'd basically drunk the Kool-Aid, and they wanted to decompose everything into everything into microservices as small as possibly they could. So the temptation here is, if you're going to do this premature decomposition, what's going to happen is, I've abstracted the name of the actual company for confidentiality, but let's say that this company, the name is Amazing Stuff. They create a lot of cool things. So they have a product that, let's call it awesome, right? It's an awesome product. So they plan to create a new offering called Super Awesome, because they have done their studies, they have done data analytics, and they've identified that, hey, there is actually a need in the market for this, and we're actually going to get revenue out of this, and they've done their due diligence, so they start developing. So initially, they identify a lot of similarities between these two products, except for the fact that one is catering to a very niche market. So they decide, hey, why not decompose the application into microservices once, and then reuse a significant part of that across the other application. What ends up happening is, as their analytics had shown them, it was targeting a very niche market. So it really kicked off, it got really, really popular, and then they had to add all of these new features to the application. And that's where they realized that now they are going to have to redo everything, because whatever change they make to the commonly shared microservice is going to impact the other application as well. So this is really the equivalent of a microservice smell. So if you're familiar with code smells, it is basically, don't try to reuse code across different microservices, across different applications themselves, and don't really be in a hurry to completely cut your application into microservices-oriented architecture. It doesn't make sense, as you're going to end up having to redo some of it. So the next one is what I like to call the three musketeers of building cloud-native applications. So the first one is APIs. Why are APIs important? The main reason is microservices like to talk. I mean, they're completely useless if they don't talk to each other. And let's say you have an application, a small application, let's say you have 100 or so microservices, and they need to talk to each other for them to contribute any real value to the application. What ends up happening is all these microservices are also being managed by different teams or different people. So many are changing simultaneously. And you really decided to go down the cloud native path and decided, hey, I'm going to use the right tool for each microservice. So now you have hundreds of microservices in a bunch of different languages. So what ends up happening is, unless you use something like a language-independent API, or you use something like, I'm not sure how many of you are familiar with Swagger. So unless you use something like that, the problem of microservices talking to each other can get very, very out of hand and can get to be a problem that you're going to spend all your time trying to solve. So what something like Swagger does, it allows you to honor the contract between various microservices. So let's say let's take a very, very simple use case, right? So if one of the microservices changed one of the return values changed from an int to a float, what is the impact on all the other microservices? And is that being broadcast to all the other teams that are actually working on on the microservices in question? And something like Swagger, it also allows you to very interactively document all the changes that you're making, because when you are building a cloud-native application and when you are following the microservices architectural paradigm, in a sense, what you're doing is you're building a very large distributed application. And if you are unable to manage it, it's going to become a big problem at scale. So the second musketeer is service discovery and service registry. So now you have these microservices, they're talking to each other, they can't seem to shut up. So every time something new comes into the picture, every time a new microservice is added, all the other microservices need to know that exists. So either you create something manually, or you can use something like a service discovery and a registry tool. So my favorite is Eureka, because that came out of Netflix. It has been hardened at scale. And within Pivotal, we actually adopted it into what is now called the Spring Cloud Services. So it's a really, really cool tool. You should go check it out. But what it allows you to do is anytime a microservice enters the picture, it broadcasts its information to the service registry. So now it knows exactly what is the host, what is the port, and if it leaves, that information is also present in the service registry. So it automates the discovery of new microservices. And what that means is that, let's say you have an application with 500 or so microservices, you're not going to have any errors at scale. Or at least you're going to be able to minimize them greatly. So the last one is fault tolerance. And this is something that's a very, very difficult problem to solve in a large distributed application. So let's say, hypothetically, you have a situation where you have a bunch of internal services, they're feeding your application, and some of them fail for some reason. So what ends up happening, very likely, is the failure might propagate to the API layer. You might have a discontinuity in service. You might experience an outage. You might end up losing several dollars in revenue. This was something that Best Buy experienced a while back, where during a peak shopping period, I think it was Black Friday, or I don't remember exactly when, they basically had to shut everything down just because they simply couldn't handle the traffic. So whatever the reason for the failure was, what ended up happening was, during a peak shopping time, they lose several millions of dollars in revenue. So is there an elegant way to catch something before it happens? So why there is. I'm not sure how many of you are familiar with or have used some version of a circuit breaker in the past, but this is a really, really great way to monitor your microservices. So what something like Hystrix lets you do is it allows you to watch something and watch a microservice or watch a part of your application that may or may not malfunction, and it allows you to isolate that point of failure. So what ends up happening in this situation is you can contain the error in case it actually starts to malfunction. Essentially what's happening is the circuit or the connection between that part of the malfunctioning application is broken from the rest of your application, and then you ideally have some kind of a graceful degradation mechanism where you might fall back to some kind of a nice looking page with puppies and whatnot and say, we'll be back soon or something like that. But it's something that you know is going to happen or might happen, and you have caught it and you have contingency plans for it. So this is, again, a problem that I see very, very frequently when customers say, hey, we need to figure out how to move from a monolithic architecture to a microservices architecture. And the biggest problem is they try to bite off too much too soon. So what ends up happening is, I even had the enterprise architect at one of the large investment banks say, hey, can we just move the entire monolithic application and deploy it on Cloud Foundry? And I said, maybe, but why do you want to do that? Because now you're moving the problem from a domain that you kind of know and you've kind of been dealing with to a domain you don't know at all, and it's not even meant for that. So the temptation to lift and shift a monolith, it's a bad one, avoid it at all costs. And if you see someone trying to do it, give them a kick or something like that. So, so the other problem is the complete opposite of that. You're trying to rewrite the entire application. So it's not going to happen like that. It has to be rewritten in bite-sized chunks. So you're trying to do too much, too fast, too soon, and this is a very, very unrealistic proposition. It's not going to happen. It might not even be possible because of the existing cloud infrastructure. And what ends up happening is there are a lot of good ideas that never ever jump off of PowerPoint, and they basically, I mean, I've spoken to CIOs and CTOs. They say that, hey, we want to do this, but every time we talk to them, there are new blocks on a PowerPoint slide, and nobody seems to know how to implement it, and they never get off it because they're trying to do too much too soon, and they try to plan for all the possible edge cases. And what that means is that the technology to solve that doesn't even exist today. So what they end up doing is they create that piecemeal architecture, adding pieces to it that may or may not solve it, and then they're kind of creating the same problem that they did with monolithic applications. So common sense, right? So don't try to boil the ocean. Identify which function can be rebuilt, and how do you figure out which function is an ideal candidate? So something that ideally will benefit from innovation, or something that is very, very hard to modify. You know, that piece of your application that seems to impact everything else, but every time you go to change it, you get things like, okay, this is too difficult to change it. It has 10,000 other dependencies. And probably the best thing is something new. Anything new that you're adding to an existing application, write it as a microservice to begin with, so that you're now creating a clear layer of separation between your legacy and your net new features. So what's going to happen is you'll notice that there is a minimum amount of impact on the rest of your monolithic application, and you're also able to, as you go along this process, a lot of the technical debt is going to come to the surface. What needs to be done, and how do you handle it in a piecemeal fashion? And it's going to allow you to very gradually, with very little disruption to your existing applications that are working, that need to work, actually move over to a newer, more efficient way of writing and deploying and scaling applications. So basically, just start really, really small, or just start really, really new. It's just common sense. So this is something I saw on Twitter the other day, where we replaced our monolith with microservices, so every outage could be more like a murder mystery. So unfortunately, this is a very, very common problem. So what is the best way to solve this? So the problem is basically, in a distributed application architecture, how do you figure out where do you start looking? And when you have something over 1,000 microservices, and this is not even a small, not even a large application, it's a fairly standard application that can run into several thousands of microservices, how do you start isolating which subset of your application should you look at? So there are several ways to do that, and there are three, what I would like to say, the three best friends basically in this situation, where it's logging, dynamic tracing, and application performance monitoring. So logging is your best friend. use something like Pivotal Ops Metrics. So Pivotal Ops Metrics, it's something that's part of Pivotal Cloud Foundry. So obviously, if you're not using that, it's not going to be useful for you. There are several other tools like New Relic, App Dynamics, Sumo Logic, Elk Stash, Splunk, and so many more that allows you to pinpoint what is happening in your infrastructure or what is happening in your Cloud Foundry deployment or your container deployment. Dynamic tracing is another extremely useful tool. So Zipkin is something that came out of Twitter, and what it allows you to do, especially in a microservice-based architecture, what it allows you to do is, let's say that ideally what's happening in a microservice world is microservice A is talking to microservice B, which is probably talking to microservice C and D and so on. And then when you're trying to isolate where there is a lag or where there's a performance lag or where there is some kind of a problem, you're going to go about it the old-fashioned way where you actually contact the different teams and say, okay, we may be experiencing an issue here. And every team comes back and says, no, we tested everything, everything's working fine. So how do you kind of figure out where the problem is? So what something like Zipkin allows you to do is it allows you to trace your request, and it allows you to see how much time it is taking at each microservice. And when you see something like, oh, this is taking 2 times the usual amount of time, then maybe that's where I should look at deeper, because it might be a caching problem, for example. So that's not something that's very evident when you just test microservices individually. And application performance monitoring tools are, again, your other best friends, because essentially what you now have, let's say in a 500 plus microservice application, is you have 500 little applications. So use something like New Relic or DripStat, or there are several other tools, and I'm pretty sure you have your favorite. So I heard a lot of things about build pipelines. I heard a lot of things about automation, and it holds true that if you automate the wrong thing, you're going to suffer massively. But at the same time, if you automate the right thing, it's also going to be extremely beneficial. So, why do we even use build pipelines? So the goal is we want to deliver tested, mature software after every iteration and after every environment that it goes through. So in this situation, what I see build pipelines being is it's essentially that transport layer that validates it at every single point. So, okay, so apparently I have 1 minute left, so I'm going to talk at a super duper fast speed right now. So essentially the point is this is not something that, there is no reason to think about build pipelines and automating everything as eventually moving to a no-ops thing in a bad way. Because the way I think about it and the way it actually is that as I see at customers is ops teams are essentially the invisible glue that hold everything together, that keep on hardening the application deployment pipeline. And the focus ideally should be on building great software. It shouldn't be on how do you deploy it. The last part is a little bit of a deviation from what I've spoken about, but this is usually a problem that I've seen in companies that are they have a tremendous amount of data, and they need to use large-scale search tools like Solr. So what ends up happening is if you have several microservices, and each microservice is talking to the others and constantly updating the databases in the backend as well, users are not going to be able to perform unified search across all of these different silos. So what ends up happening is your search data is stale. So this is what one of the large financial companies in the world actually employed to actually get rid of this problem. So what they did was they had an enterprise-wide data bus. In this situation, they were using Rabbit, but you can also use something like Kafka, and all the microservices were publishing asynchronously interesting points to that enterprise data bus, and then you have, if you're using Solr, you have search event listeners. So these are constantly listening to these events, and they will update your search indices in real time. So basically what you're doing is you're going from a static data push model to you're basically doing a real-time data pull model. So again, to summarize, don't ignore the sweet spot. You don't have to choose between risk mitigation and innovation. Don't try to do monolithic microservices. Don't go ahead and be wary of microservice smells, and use a service registry, service discovery, fault tolerance, and APIs extensively. Don't try to do too much too soon. And you don't have to treat a microservice like a murder mystery. Automation is your friend. Use build pipelines and use as many of them as possible. Don't use them the wrong way, please. And siloed search is going to ruin your customer experience, and it's going to cost probably several thousands of dollars to the company. So that's it. Questions, comments? Everybody wants to eat, I guess. Okay.